Transversals and angle pairs. Identifying lines and planes. Two lines are parallel when non-intersecting lines lie in the same plane. If we look at the image, you see line M and line N. Both lines have red arrows on them. Those red arrows indicate that they are parallel. Notice they do not intersect, and notice they both lie in plane T. So line M is parallel to line N. You should be able to identify that. If two lines are skew, then they are non-intersecting lines that exist in different planes. Again, if we look at the drawing, we see that line K is a vertical line. It intersects line N, so those are intersecting lines. We need to find a different line that doesn't intersect K, and that would be M. They exist in different planes. We see that line K only touches plane T at a single point. Line K itself lies in an entirely different plane, so we should be able to identify that line M is skewed to line K because they exist in different planes. And two non-intersecting planes are called parallel planes, and from the image we should see that plane T and plane U do not intersect and therefore are parallel. The parallel postulate. Given a line and a point P not on the line, then there exists exactly one line that passes through the point P and is parallel to the given line. You can see that the given line is in black and point P is not on the black line. The red line represents a existence of a unique line, exactly one line, that is parallel to the line L but passes through P. Let's take this time to look through some algebraic examples that use the parallel postulate. So in this problem, we're asked to write the equation that passes through point Q and is parallel to the given line. To do this, we're going to use something called the point-slope formula. And the point-slope formula is y minus y1 equals m, and then parentheses x minus x1. And we're going to substitute into here the x and y coordinate of a known point. And the m, we substitute the slope in that we want to use. So that means we could say that 6 is our x1 and negative 2 is our y1, and our slope m is equal to 1/2. Because it said parallel, parallel means equal slopes. So we can take this now and say I'm going to substitute into this formula. So I have y minus my y1 is negative 2. So y minus negative 2 equals my slope is 1/2. 1/2 parentheses x minus my x1 is 6. And we can simplify. The double negative makes this y plus 2. And I can distribute my 1/2 through the parentheses, getting 1/2 x minus 3. And when I subtract 2 from both sides, I'm left with y equals 1/2 x minus 5. And this is the slope-intercept form of the linear equation that passes through point Q and is parallel to 1/2, or the linear equation given to us. So if we wanted to plot this line, we would start at negative 5. Here we go, negative 5, and the slope says go up 1 and over 2. So go up 1 over 2, put a point, up 1 over 2, put a point, up 1 over 2, put a point. We see we landed right through Q, and we can say that our linear equation passes through Q. Let me do a better job with that linear equation for that graph. So our linear equation passes through Q and is parallel to the given line. There we go. And that's from the equation that we just found. And this is to illustrate the parallel postulate, that once you have a line and a point not on the line, that there's exactly one parallel line that will pass through that point. So here's a second example. You can pause here and solve it on your own. Write the equation that passes through point P and is parallel to the given line. So once you've completed, you can unpause and check your answer. So we will begin by writing the point slope formula. We'll label our point x1, y1, and our slope is negative 2/3. We will plug all of this information into the point slope formula. So we distributed the negative 2/3 through here. Now I'm going to add 1 to the other side. I see here that the 3's cancel, so we have negative 2 plus 1. So finally we have negative 2/3 x minus 1. Let's see if this is correct. We'll check it out by graphing it. We start at the y-intercept of negative 1, and we go down 2 and to the right 3. So 1, 2 down, 1, 2, 3 to the right, 2 down, 3 to the right. Or we could reverse that. Instead of down to right 3, we can go up to left 3, and we see it lands on the point P. Now we can graph a line that goes through here. Let's extend that line a little bit. And we see our equation does indeed pass through the point P and is parallel to the given line. Some of the odd examples involve horizontal and vertical lines. So anytime we have y equals a number, it is a horizontal line. So y equals 2 would be horizontal through y equals to 2. What it means is where all the points have a y coordinate of 2. So our point R is at 8, 3. We just have to draw a horizontal line through there. And if I draw a horizontal line through R, we see that's where all of the y coordinates are 3. So y equals 3 is parallel to y equals 4 and passes through 8, 3. So basically with horizontal lines, you just need to look for the y coordinate and write y equals that y coordinate, and that'll be the parallel line. When x equals a number, those are vertical lines. That means all the points with the same x coordinate. So we see the x coordinate here is 5. So if we were to draw a line through x equals 5, that would pass through point S and be parallel to the given line. X equals 5 is parallel to x equals negative 3 and passes through the point 5, comma, negative 6. Next is the perpendicular postulate. Given a line and a point P not on the line, then there exists exactly one line that passes through the point and is perpendicular to the given line. Again, notice line L in black and point P not on the line. The red line represents the existence of a unique line that passes through point P and is perpendicular to line L. Let's look at some algebraic examples using the perpendicular postulate. So here in this question, it asks that we write the equation that passes through a point Q, but this time it's asking that we are perpendicular to the given line. So we are still going to use y minus y1 equals m times x minus x1, which is our point slope formula. We're still going to label our points that we know as x1 and y1. However, we need to find the perpendicular slope. So if m is 1/2, then perpendicular to m is negative 2 over 1. Perpendicular slopes are negative reciprocals. So just as an example, if m is equal to negative 1/4, then perpendicular to m is equal to positive 4 over 1. It was negative, and when you take the negative of a negative, it becomes positive. So the perpendicular slope became positive in this case. So now that we have our point, which is 6, negative 2, and our slope, which is negative 2, we can plug into our point slope formula. Distribute the slope through the parentheses, and then subtract the y1 from both sides. And we get that y is equal to negative 2x plus 10. So if we take 10 as our starting point, and negative 2x is negative 2 over 1, which means 2 down, 1 over, 2 down, 1 over. We keep doing that, and we see that we land on our point Q. So it does pass through the point, and it is perpendicular to the given line. So if I draw this right through, we see that our line is perpendicular, and it passes through the point. So similarly, we have equations that are just y equals or just x equals. So we're dealing with horizontal or vertical lines. So horizontal is perpendicular to vertical. And if we want to draw a perpendicular line through R, we should notice that it's a vertical line, so it's going to be x equals. What is the x coordinate of R? It is 8. So x equals 8 is perpendicular to y equals 4 and passes through 0.83. Identifying transversals. A transversal is a line that intersects two or more coplanar lines at different points. If you look at the image below, we have multiple lines that intersect two or more lines at different points. That means that every line depicted here is a transversal. Just to practice this concept, if we look at question 1, which line is the transversal? So you have lines M, N, and P. So is M a transversal, line N, or line P, or is there no transversal? Well, the definition says a line that intersects two or more lines at different points. And we see that line M intersects line N and line P, so that's two lines it's intersecting, and it's intersecting them at different points. So question number 1 should be A, line M is the transversal. When you look at question number 2, notice that all three lines intersect in the same point. They're not intersecting in different points. So again, if you recall the definition of a transversal, which is a line that intersects two or more lines at different points, you should come to the conclusion that there is no transversal. So your answer would be D. Try question 3 on your own. Which line is a transversal? The answer is line K, which is answer choice C. And question number 4, you have lines A, B, C, and D. Which line is a transversal, or is there no transversal? Again, you should answer choice C, which is line C, and that is because it intersects 2 or more lines at different points. There are angles formed by transversals, and the 4 types of angle pairs that we will be interested in are corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. Let's look at the definition of these angles. So when we're looking at the definitions of these special angle pairs, we can see that in this first one here, the 2 angles are corresponding angles when they have corresponding positions. So when we're talking about those positions, we're talking about related to the intersection points. So notice that angle 2 is in the upper right-hand position of the intersection, and angle 6 is in the upper right-hand position of the intersection. That's what we mean by corresponding positions with respect to where the lines intersect. If we look at the next angle pair, the alternate interior angles, they lie between, and that's because this is the interior between the 2 lines, and they alternate which side of the transversal they're on. They switch sides. So we see that it's switching sides of the transversal, but it's also switching which line it is adjacent to. So it's alternating both the side of the transversal and the line it is adjacent to. If we look at alternate exterior angles, now we see that we're no longer in between the 2 lines, we're outside of the 2 lines, that's the exterior, and we see that we're alternating what side of the transversal we're on, and also which of the 2 lines we're adjacent to. So it's alternating lines and transversal again. And the last one here is consecutive interior angles. Again, we are on the interior region in between the 2 lines connected by the transversal. And consecutive means that they're not switching sides, they're on the same side. And it's even, sometimes some books call this the same side interior angles. So that's an alternative name for this, same side interior angles, but the formal name is consecutive interior angles. So they lie on the same side of the transversal, but notice that all of these angle pairs are adjacent to 2 different lines that the transversal intersects. So if we practice this concept of angle pairs, looking at the diagram, what angle pair would you say represents angles 1 and angle 5? Are they corresponding, alternate interior, alternate exterior, consecutive interior, or none of the above? Out of the choices given, you should select E, none of the above. Angle 1 and angle 5 form a different type of pair called a linear pair and do not require a transversal. Looking at question 6, angle 2 and angle 7, which of our special angle pairs would you classify that as? Because angle 2 and angle 7 are in between the 2 lines intersected by the transversal, they are interior angles, and because they alternate sides of the transversal, they are alternate interior angles. Your choice should be choice B. Consider question 7. What is the special angle pair for angles 6 and 8? Your answer should be choice A, corresponding angles. Question 8. What pair would you classify angle 4 and angle 5 as? Alternate exterior angles, choice C. That is because the 2 angles are on the outside of the angles, on the outside of the lines intersected by the transversal. They are in the exterior region, and they alternate the sides of the transversal they're on. And question 9, how would you classify angle 2 and angle 7? Again, answer choice B, alternate interior angles. And question 10, how do you classify angle 3 and angle 7? And you should answer none of the above. They are a linear pair. So that's the end of the lecture notes for section 3.1. Take your notes, practice the worksheet. Let me know if you have questions.